In this video lecture, we will be solving this problem move zeros, which is a Leetcode easy problem, but it is a very popular interview task. So in this problem, we're given an integer array nums. We have to move all zeros to the end of it. So the integer array contains negative integers, positive integers as well as zeros. So in this problem we have to move all the zeros to the end of the array while maintaining the relative order of the non-zero elements, and the constraint is that you must do this in place without making a copy of the array. That means the optimal solution that we arrive at must not use any extra array to temporarily store the elements. Let's see the input and output format. So in the input we will be given an array of n integers containing positive as well as negative integers. It also contains zeros, and in the output we have to return the modified array which has all the zeros of the original array shifted to the end of the array. Fine. Let's see the constraints of the problem. The length of the nums array goes up to 10,000. That means the largest array that we can have has a length of 10,000, and the integers in the nums array may go up to minus 2 raised to the power 31 in the negative side and 2 raised to the power 31 towards the positive side. Let's better understand the problem statement using an example. So let's see this example. So this is the example given in the problem statement. We have a nums array of size 5 containing 2 zeros here at the first position and here at the third position, and we have to move these zeros towards the end of this array while the relative order of these non-positive integers must stay the same. That means the order must be 1, 3 and 12, and the answer array is this. It contains integers in the same order as they are given in the nums array while the zeros are shifted towards the end of the array. So this is the answer for this particular array. So we can observe that the easiest way to do this task is to create a temporary array. Let's call it temp, and we count the number of zeros in this array that we have, and then we traverse over this array nums and push the positive integers into this temp array. So this will store all the positive integers into this temporary array in the same order as they are given in the nums array. Then we have the count of 0 in a separate variable, and we push the same number of zeros into this temporary array at the end, and hence this temporary array will contain the required array which we want to find. Then we finally copy the elements of this temp array into our original array. So this is the first strategy to solve this problem, which is the most naive strategy. So here's the nums array. This is the variable to store the number of zeros in this nums array, and we start traversing this array from the first position, and this is our temp array, and we start traversing this nums array from the first position, and whenever we encounter a positive element we push it into the temporary array, and in this way we have our positive integers pushed inside this temporary array. Fine. Then we have our count of zeros as 2, and then finally we push these zeros, that is 2 zeros, at the end of this temp array. Fine. Now this is the required array which we need, and we simply copy the array temp into the nums array. So replace each element of the nums array with each element of temp array, hence giving us the final nums array as. So this is our answer. Fine. A very easy approach to solve this problem. Let's see the implementation of this approach. So this is the move zeros function which takes in the nums array. First it calculates the length of the nums array, then it initializes an integer variable nums zeros which counts the number of zeros in the nums array. Then we iterate over the nums array and we count the number of zeros in this array into this variable nums zeros. Then we initialize a temporary array answer. So instead of calling it temp, we are calling it answer here, and then we iterate over the nums array and we store all the positive integers into this answer array. Then we simply push num zeros at the end of this answer array, and finally we copy this answer array into the nums array, and hence nums will store our final answer. So this is how this function is working. So it's a very naive way to solve this problem. Here we are using extra space, which is this answer array. So let's see the time and space complexity for this solution. You can see that we are iterating over the nums array twice, and hence the time complexity would be linear. So this is the time complexity, which is linear, and the space complexity is also linear because we're storing the elements of the nums array into this answer array. But in the problem statement, we're given that we must do this problem in place without making a copy of the array. But in this approach, we are making the copy of the array, and this is not allowed. We must modify our original array somehow to shift the zeros at the end of this array while keeping the relative order of the positive elements same. Okay, so let's see the second approach to solve this problem. So rather than thinking of shifting the zero elements towards the end of the nums array, we can think in the reverse order, that is shifting the non-zero elements towards the start of the array. How we can do that? Let's see. So we keep a variable at the first position initially. Let's call it last non-zero index. So let's call it L. So we start L from the first character and we iterate over the nums array from the first position, and this pointer checks for the non-zero elements. So this pointer checks for the non-zero elements. So we check if this element is non-zero or not. No, it's zero element. So we move our I pointer to the next position. So now I is here. So do we find a non-zero element? And the answer is yes. The element at ith position is non-zero, and hence we simply copy this element at ith position at the L position. So we copy this element at the ith position at the position L. So we copy 1 here. So here 0 becomes, then we move the pointer L and I by 1. So L comes here and I is here. We see if the character at I is non-zero or not. It is not non-zero. We have 0 here. Therefore, we move our pointer I to the next position. So I comes here. Here you can see the integer is non-zero. So since it is non-zero, we copy this integer at the L position. So we copy 3 here and we move both pointers by 1. So I is at the last integer while L is at the third integer. And here we check that at ith position the integer is positive. So we copy this integer at the lth position. So here we have 12. Fine. And we move both pointers by 1. So L goes here. So here you can see that I crosses the boundary of the nums array. So we stop here. And here we conclude that we have stored all the non-zero elements in the starting window, and whatever the remaining integers that we have starting from the position L up until the last position of the array, we must have zeros stored. Fine. And hence we start from position L and we go up until end of the array while storing zeros at all positions. So this is our final array. This array contains all the non-zero integers at the starting window and all the zeros at the end of the window. So all we did, we took 2 pointers. One of the pointers simply traversed over the elements starting from the first element, and another pointer I was used to keep track of the non-zero elements. And whenever we found a non-zero element, we simply copied that element at the lth position while moving both the pointers ahead by 1 position. So this is how we modify the nums array in place to get our answer array, and hence we can return this array right from here. So let's see the implementation of this approach. So this is the implementation for this approach. You can see this move zeros function takes in the nums array. We take a pointer or an index to the nums array, represented by last non-zero index, and we calculate the length of the nums array. Then we iterate over the nums array starting from the first position. Whenever we find a non-zero integer, we simply copy that integer at this position, represented by the index that we declared here, and we move both the pointers ahead by one position. So here we are incrementing the variable last non-zero index by 1, and here I'm incrementing the array index I by 1. Fine. So this is how we modify our array, and it is used to shift all the non-zero elements towards the starting of the array. Finally, we start from this index and now this index, that is last non-zero index, stands at the very next position to the last non-zero element of the array, and hence we start from there and we move till the end of the array, and we store zeros all the way till the end, hence shifting our zeros towards the end of the array. So this is the optimal strategy to solve this problem. Let's discuss the time and space complexity for this strategy. So here you can see that since we are iterating over the nums array once, the time complexity is linear, while the space complexity for this particular implementation is constant because we are not using any extra space for temporarily copying our original array. We are simply performing the computations in place, and hence the space complexity is constant. So let's move on to the code implementation for this problem. So this is the solution class where we have a move zeros function which takes in the nums array and returns the modified nums array. So we declare a last non-zero index variable which is used to copy the non-zero elements towards the starting of the vector or array. Then we calculate the size of the nums array. Then we iterate over our nums array, and here whenever we find a non-zero element, we simply copy that element at last non-zero index position while moving our last non-zero index pointer ahead by 1, so that next non-zero integer can be stored as well at the very next subsequent position. Then we have our last non-zero index pointer at the very next position of the last non-zero element of the array, and the remaining elements must be 0 elements, and hence we store 0 at the remaining positions. And finally we return our nums array right from here because this nums array is modified and contains all the zeros towards the end of this array. So this is the implementation in C++. Let's see the implementation in other languages. So this is the implementation in Java, and this is the implementation in Python language. So that's all for this video. If you like the video, then make sure to like it and subscribe to my YouTube channel and give your feedback in the comments below. I will see you in the next video. Till then, take care. Bye bye. In this video lecture, we will be solving this problem move zeros, which is a LeetCode easy problem.